Oh no! I've done it again! Oh man! Oh, can't believe it! I'm trying to avoid this, but oh man! Hang on, guys. I'll be right with you. I'll be there in just a second. I got everything's under control. Trust me, guys. Everything's under control. I promise. I promise everything's under control. Give me just a second. Just a second. Hang on, just a second, guys. I think I about have it. Oh, almost got it. Hang on. I apologize for the delay. Yes. About there. Working very hard to get this resolved and just, yes. Okay, sorry about that, guys. Apologize. Here we go. Okay, very good. Hey, Mr. Wilhelm here. Sorry about that. Had a little bit of experiment going on that didn't necessarily go the way I wanted it to go. Okay. All right. Anyway, to what we're here for today. We're here to talk about scientific method and going through an experiment in the correct way, and so that our results of our experiment are valid and reliable. So, in any experiment that we do, we'd always want to make sure that we take all the correct safety precautions. We would want to wear closed-toed shoes to make sure that we cover up our feet. We would want to make sure that we wear lab aprons if we're using fire or flames, tie back our hair, and then obviously eye protection. So, and goggles. So anyway, we're going to perform a sample experiment today, and that way you can get a better understanding of the correct steps of the scientific method, and then how they increase the accuracy and results, validity of an experiment. Today, I'm going to do the old drops of water on a penny experiment. This one's been around forever, but it still is a good example of an experiment. And I'm going to take these off. Number one, I'm a little hot. Number two, I'm just using water today, so I'm not too scared about water. But we're going to see how many drops of water will fit on the head side of this penny and how many drops of water will fit on the tails side of this penny. The first thing we always do in an experiment is we identify what is the problem. What are we trying to figure out, and what are we trying to get the answer to? Our particular problem today is we want to know what side of the penny will hold more drops, the tail side or the head side of the penny. So I have my penny, I have my water with a beaker, a pipette, and a paper towel to mop up the mess. Okay. Always, additionally, very important, is your lab write-up, your paper, and your pen. Okay, so first step, identify the problem. We identified the problem. Second step, gather information. We need to find out more information about the problem. In this particular experiment, I might see, maybe measure the surface area of the penny. I might investigate water tension and how that affects my results. And then also, I might, read about what pennies are made of and composition and what might be in the water and how different types of water, tap water versus distilled or purified water, might affect my results. So I'm going to gather information so that I can come up with basically a hypothesis, an educated guess, what I think is going to happen. What might be the results here? What do I think is going to be happening at the end of this experiment? So I have my penny, and I'm going to guess that the tails side of the penny is going to hold more drops. I might even speculate and try to provide a number. But right now I'm just going to say the tail side is going to hold more drops than the head side of the penny. So once I have my problem, I have completed my background information, I've done my research, I have come up with my hypothesis, then I'm going to start to perform the experiment. Okay, you guys all know what this experiment is. I take the penny, I put it down, I take drops, and then I start to count. 1, 2, 3, 4, 5, 6, 7, 8. And I continue this process until the water falls off the penny. Okay? As I'm going along, I'm always recording my data. Okay, I write down my problem. I write down my research. I write down my hypothesis. I write down my materials that are required for this experiment. I write down the list or procedural steps that I go through when conducting this experiment. Okay, what I want to try to avoid in this whole thing is I want to try to avoid variables, little bitty things that might mess up my experiment, might change or harm my results. Okay, it might cause my experiment to not be valid. Okay, so I go through and let's say that the head side holds 20 drops and the tail side holds 25 drops. Okay, not done. Okay, I've performed the experiment one time. That is one trial. I need to perform as many trials as I possibly can. That might be 5 trials, it might be 10 trials, it might be 20 trials. Okay? The more times I can perform an experiment, the better. Okay? The more valid my results. And there's that word. It keeps coming back. Valid. The more valid my results are going to be. So let's say I perform this experiment 10 different times. Okay? Every single time, the tails side of the penny holds more drops than the head side of the penny. After many, many trials, okay, I can conclude that tails side is going to hold more drops than the head's side. And I can also go back to my hypothesis and say my hypothesis is either correct or it's incorrect. It's okay if it's incorrect. I made an educated guess and I was wrong. Okay? And if that's the case, I'd go back and I'd repeat the experiment, try to figure out what the correct hypothesis would be. In this particular instance, my results were the same as my hypothesis. So my hypothesis would be correct. As always, writing. Okay, writing down every last step I possibly can on here. Okay, trying to minimize the variables, take out the little things that might mess up the experiment, might not make the experiment make the results valid. Okay, so in review, I write down the problem. Okay, I identify the problem and I write the problem down. I also am going to record what the materials are. Okay, I'm going to conduct any research or use any prior knowledge that I may have. Use any prior knowledge to determine what my hypothesis is going to be. I would go through and conduct the experiment. When I'm conducting the experiment, I'm going to write down each and every last little step in order to complete the experiment. Okay? And then I'm going to, at the end, after completing the experiment, determine, is my hypothesis correct or is my hypothesis incorrect? Very good. I hope you guys get some information out of this video and are able to apply this information to your candle lab that you guys will be doing tomorrow. Maybe you can think about some things that you did correctly or maybe incorrectly during that lab. I'm sure you already figured out several of those things now. Sorry for the slight problem at the beginning of the video. We'll try not to ever do that again. I'm hot and sweaty and this kind of it. Anyway, Mr. Wilhelm signing off. You guys have a good evening and come ready to learn tomorrow.